Welcome back, everybody. This video we're going to be talking about how to transform functions, function transformation. And it all starts with the function f of x, and we're going to be doing things to functions to move them. When we say transformation, we mean shift left, shift right, shift up, shift down, and then even reflecting over the x-axis or the y-axis. All right, so let's first talk about reflection. Say I have function f of x. If I make every sign in the function the opposite, that's going to reflect the function over the x-axis. And I'm going to demonstrate all of this on Desmos here in just a little bit. Now, however, if I just change the sign on the x variable within the function, that's going to rotate it around the y-axis. Alright, so depending on where you put a negative sign, either change every sign on the function or just change the sign on the x variable. It depends on whether you rotate around the x or the y-axis. When I say rotate, I also mean reflection. We're also talking about reflections. Alright, let's talk about shifting a function up or down. Okay, so we have function f of x, and say we want to shift it up. If we shift it up, the function will need to be added. We'll have to add a number on the end. I mean, that variable is k, the number that's the variable they use just to show whether a function is shifted up or down. Say we want to shift a function down. Well, if you associate positive with up, associate negative with going down. So f of x minus k, have a negative number at the end of the function on the tail end. That's going to tell you the function shifts down. Alright, and then finally we need to discuss shifting left or right. And given the up and down was sort of intuitive, we have a positive meaning up on the xy axis, positive y values mean go up, negative means go down. With shifting left and right, it's a little bit counterintuitive with respect to the x-axis. Alright, I'm going to use variable h to denote shifting left and right here. Okay, we're going to have f of x, and notice I left some space here within the function. Alright, so if I shift to the right, I'm going to have minus a number, some number, alright, and you're going to see that within the function, So it's only going to affect the variable, not if there's any other things that are being added or subtracted the function. It's just in and around the variable within the function. But notice it's minus h. On the x-axis, positive values are to the right, so you would assume plus h, but no, that's not how it works. And then shifting to the left would involve x plus h. Alright, and we're going to just kind of see this in action here. Let's switch on over to Desmos, and I think we're going to just look at function f of x equals x, just plain old x. Alright, and in here we have the function, see our x and y variables here. We also see the grid here. Keep in mind Desmos is really nice, it allows you to move things around with just by clicking and dragging. Alright, let's show how I would reflect this over the x-axis. So I define my function here on Desmos, and feel free to try this. I encourage each of you to try this out. Plug in any function you want. I'm just using plain old simple function x. I'm going to flip this over the x-axis by putting a negative out in front. Alright, and then let's see how that looks. Clicking on it, there you go. Pretend that this is a piece of paper and we are folding this horizontally on the x-axis. Notice the two functions match up perfectly. What I did is I reflected over the x-axis. Now the same can be, I can do the same thing. Let's turn this off for a minute. Reflecting it over the y-axis. Now I know essentially it's the same because it's the, this function is so simple. F of x equals x is a very simple function, but I want you to also now think of this as reflecting over the y-axis. Pretend it's a sheet of paper you're looking at, and if you fold this paper right on the y-axis, notice how the function is lined up perfectly. So that is just demonstrating how you reflect it over the x and y axis. All right, now let's shift this, let's practice shifting it around a little bit. We see on the graph our line is the black line, f of x equals x. I want to shift this up one space. There we go. Notice it was shifted up 1. If I go look here from the origin, I can just, if I pick one value on the x, it was just shifted up 1. Now look what happens when I minus 1. Now it's down below, essentially. It's kind of hard depending on how you look at it, but if you look in terms of x values, you can see this, the green line is the shifting of that function below. All right. Now let's look at this from a left and right point of view. Let's say I want to shift right. Remember it was counterintuitive. I'm going to minus 1. See how it was shifted to the right 1 by minus 1. And then let's do plus 1. Notice how it was shifted to the left. All right, so that's just a very simple demonstration of function transformation. Desmos allows you to do this really easy. All right, let's try some multiple choice questions and try out some of these ideas here. It says, which statement correctly describes the relationship between the graph of f of x and the graph of g of x? G of x is f of x, same function, but we just add 3. Notice the plus 3 is at the end. All right, so it's kind of like that k variable we were talking about. So because of that, we're going to be shifting it up. Letter A here describes it. We're translating it, shifting it up 3 units. That's what the plus 3. If it was minus 3, we'd be shifting down. All right, now look where they put it. They said same problem, except graph of f of x and the graph of g of x is f of x minus 3. It's inside the function. We're shifting it left and right if we're inside, and now that counterintuitive part. We go minus 3, we're shifting horizontally. Is it left? Is it right? Minus 3, you might assume shifting to the left because of the negative 3, but no, it's the opposite. We're actually shifting to the right 3 units. Letter C here translates or shifts this function to the right 3 units. All right, now we actually have a real function to look at here, and we really didn't just get into this too in depth on Desmos. The graph of g of x is the graph of f of x plus 9 reflected across the x-axis. So there's that x-axis we were talking about. And if you reflect it across the x-axis, basically, here's f of x. And if I want to do the x-axis reflection, I'm going to have the negative outside, meaning every sign in the function gets changed. So in this particular example of x plus 9, I'm going to change all the signs. I'm going to have a minus x and a minus 9. If I were to graph both of these functions, we would see, here letter A is our right choice here. You could try this on Desmos too. X plus 9, graph that, and then also graph negative x minus 9 underneath it. You can call it g of x, and you can see how those are the reflection of each other over the x-axis. It's almost like the x-axis is a mirror, and you're looking at a reflection on either side. Let's look at another one here. The graph of g of x is a vertical stretch on the graph of function f of x by a factor of 10. Which equation describes that? And that's something we didn't quite show. You can multiply a function. Okay, so let's say we have f of x. And if you multiply it by a number, if a is greater than 1, but also if a is greater than 1, but if a, basically if we're saying between, if a is greater than 1, it's going to be a vertical stretch. That actually stretches out a function, and I can show that on Desmos here. It stretches it vertically. However, if a is less than 1, but also greater than 0, meaning a fraction, it will shrink it, stretch it horizontally, or some say compress. Let's have a quick look at that here and try that out here. Back to our function f of x. Let's say I want to multiply f of x by 10. See, so all it did was change the slope, but in essence it sort of made the function skinnier. We quote-unquote stretched it out thinner, and this is by a factor of 10. But look what happens when I make it 1/10. Yeah, I'm basically affecting the slope. So it kind of stretched it horizontally or compressed it. It's kind of a weird way to look at that. You know, I suggest trying it out with x squared. That's a quadratic. You can try all these transformations with x squared, and you kind of see the shifts and the stretch and the shrink. Let me show you real quick. If I did 10, yeah, see how much skinnier that is. And then let me change this to 1/10. Now it becomes wider. So yeah, you can kind of see that with a quadratic a little better. So in this problem, by a factor of 10, that just means, yeah, we're multiplying it by 10. We're putting a 10 out in front of the f of x. And then lastly, it's kind of a comparison here. So we have f of x. Let's compare these two functions. What transformation takes the graph of f of x, which is this, 3x plus 8, to the graph of g of x, which is 3x plus 6? Well, let's have a look at each of these item by item so we can kind of see that comparison. Here's g of x, and writing these right on top of each other, you might see this a little bit better. 3x plus 6. So the only difference is the number we're adding at the end. If you look at going from 6 to 8, we did a -2. So we can kind of think of that as -2 as that k number we talked about earlier, shifting it up or down. Since it's a minus, we're shifting it down 2 units down. D is the right answer here. Alright, I hope this helped. Just give you a primer over transforming functions, shifting it up, down, left, right, reflecting over the x or the y, and also stretching a function vertically or horizontally. Thank you for watching.